Number 5, a 2-kilogram otter starts from rest, right? So that's an initial velocity of 0. So a 2-kilogram otter starts at rest, initial velocity of 0, at the top of a muddy incline that is 85 centimeters long, right there. And actually, you know what I'll do? Let me change that into meters real quick. So 0.85 meters. That'll be better for all of my calculations later. Much better than centimeters. And slides down to the bottom in 0.50 seconds. What net force acts on the otter along the incline? So if I'm trying to calculate net force, I know that I'm still going to use my awesome thermodynamic equation here. And so I need to have both a mass value and an acceleration value. Looking at the way that the question is set up, I have a mass value, but I do not have an acceleration value. With that in mind, it must be that I can use these two terms here, the delta x and the delta t, to determine what acceleration is. And then once I've determined what acceleration is, I can plug that into this thermodynamic. Now, if the object is starting from rest, right? From rest. And so that would be x is equal to I delta t plus 1/2 a delta squared. Right, so here's one of my favorite kinematics. But if the value for vi is 0, that means I can get rid of this entire front part, and so I'm left with 1/2 a delta t. Now look at what I have going on here. I have a delta x, which I've been given by the equation, by the question, and then I have a delta t, which I've also been given by the question, leaving only a, which I can solve for. And so I will rearrange this equation to solve for a. So I'll finally have a is equal to 2 delta x divided by change in time squared, which, given the values in this question, is going to be 2 the 0.85 meters. Remember, I need to have all of my units agree, so I'm not going to use centimeters. I'm going to turn that into meters. And then I have 0.5 seconds. And don't forget to square that. If you're going to mess up this problem, probably you're just going to plug in 85 right here as opposed to 0.85. And that's going to cause the units to not agree. The other thing you can do to mess this up is forget to square the 0.5. Now, once I carry out this calculation, my calculator says that the acceleration is 6.8 meters per second squared. Now, remember, the question is not asking what the acceleration is, it's asking what the net force is. I have calculated this value so that I can plug it in for acceleration. So now I can actually go to calculate my answer. F net equals MA, which is 2.0 kilograms and 6.8 meters per second squared. Multiply those out, and again, with two sig figs here, the calculator is going to want to tell you something like 13.6, but with two sig figs, 14 newtons. See if I can get all that on the screen at once. Kind of close. Not quite.